So this is the next problem, the lakes. The statement given in the problem is you are given an infinite grid A of non-negative integer, the value of A of ij represent the depth of water at the I through and the j column. The lake is a set of cells such that each cell in the set has a of ij greater than 0 and there exists a path between any pair of cells in the lake by going up, down, left or right a number of times and without stepping on a cell with a of ij equal to 0. The volume of a lake is the sum of depth of all the cells in the lake. Find the largest value of a lake in the grid. So the problem is clearly said that there are given a grid which represent a lake. Like if a of ij like this value, if this value is not equal to 0, then this is part of the lake. After that, the adjacent element which is not equal to 0 means its depth is not equal to 0, then it is also a part of the lake. Like the lake is like this. This is the lake. The blue part is the lake. So we are just have to calculate the maximum volume of the lake. So what is the maximum volume? How can I get it? Like here it is clearly stated that the volume of a lake is the sum of depths of all the cells in the lake. So in a particular lake, the sum of all the cells, the sum of this all the cells is the depth of this particular lake. We have to find, just find it. So as so the inputs are t to the power 4, the test cases in an m, which is less than equal 1000 and each value of it will be 1000. So we guaranteed that sum of n into m over all test cases does not exceed 10 to the power 6. For each test case, output a single integer, the largest volume of the lake in the grid. So we just have to uh, tell the largest volume of the grid. So as we can see that here our test case, the time complexity is given 3. So we can just perform 10 to the 3 into 10 to the power 8 operation. So we can perform this operation. So as the test cases in the test cases, the maximum range of n and n will be 1000. So we should always travel through this range. So 10 to the power 6. If we just traverse through the grid uh, once. So this is the operation and the overall complexity will be 10 to the power 6 to traverse through the grid. Okay. So just we have to just tell the depth of the lake, each lake, the maximum depth of the lake of a lake which is present in the grid. So we can just simply apply the uh, BFS in it and we can simply we can just apply DFS in it and we can get our solution. Sorry, it is not BFS, it is DFS. So yeah, so first of all we have to traverse through the grid and we will check that uh, what what we always do in the BFS, like yeah, one second. Yeah, so we should always maintain uh, another grid to check the cell is visited or not. If it is not visited, we can start from here. Then we will check and we can add this value to our answer. It is not, if it is not 0, then we can check its neighboring element which is not 0 and not visited or not. If it is not visited and 0, we can take it. If it is then the adjacent is not visited, we can take it. 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 Not visited, take it. Not visited, take it. Not visited, take it. Not visited, take it. We can just randomly just we can go with the defense. We can go to the path which is possible from us, and we can just mm, make this array. We can just make this array which will denote the path which we gone through, and we will travel through a path one time. We can just travel to our path and just mark it into the visited array so that we do not traverse uh, multiple times with the same path. So the grid will be so the overall time complexity will be our in NQM, which is approximate 10 to the power 6. Okay, so with this complexity with the DFS algorithm, we can uh, very easily get our answer. So here's the answer. Like we just uh, traversing through the taking the input, then we are just maintaining answer variable which will store the maximum answer, and we just traversing through the grid and checking if it is possible to start the DFS from here or not. If it is possible, then we are just making the total value which is globally declared here equal to 0, and just adding our answer and just uh, making that path true so that we do not traverse multiple times in future. So and we are taking just the path like in this vector dr vector we are just asserted some value. If we add this values with I and j, then we can just traverse uh, um, up down left and right. So these are the values. So we are just checking, adding this value, and just we are just simply checking that if we are able to go to that uh, particular place or not, particular cell or not. So we are just checking that. Then we are just uh, marking that particular path which is visited, and after that, after the all operation, after all traveling the all direction, we are just returning from our recursive function. So from here we will total will be the total sum which is travel through the DFS, and we are just taking the maximum from the answer and the total. So after that we are just printing our answer. And here the memset function is used so that for the next inputs, the next test cases, the visit array will be empty or visit array will be 0. So this is the answer.